Here, question number one, which of the following conditions favors the existence of a substance in the solid state? At low temperature, at low temperature, generally molecules are at slow motion and strong cohesive forces between them. Strong cohesive forces. These two forces hold the constituents together. Together. So answer is that leads to solid state. So answer is option 2. The question number 2, which of the following is not a characteristic of a crystalline solid? As everyone of we know, the crystalline solids are anisotropic. Anisotropic. What is mean by an anisotropic? This anisotropic is a special characteristic of a crystalline solid source, different physical properties, in different directions, like refractive index and we have a electrical resistance and all. So anisotropic in nature. Anisotropic means a solid shows a different physical properties in a different directions. Here I can say isotropic is isotropic is the property of amorphous solids. Anisotropic is a property of crystalline solids. So answer is B. Question number 3. Which of the following is an amorphous solid? Graphite, quartz glass, chrome alum and silicon carbide. Here among these quartz glass is SiO2 is amorphous due to short range order constituents. Here one important point, quartz. Quartz is a crystalline solid. Don't confuse. And quartz glass is amorphous. Question number 4. Which of the following arrangements shows a schematic alignment of magnetic moments of antiferromagnetic structure? Here they given antiferromagnetic structure. Antiferromagnetic structures are the domain fields cancel each other. Domain fields cancel each other. Cancel each other. If you see in option D, alternative positions we have first domain and second domain spins are opposite in direction, and the third one and the fourth one spins are opposite to cancel each other, and the fifth one and the sixth one domains are opposite. So total spin of this molecule is become 0. Total spin is 0. So this molecule is the arrangement of antiferromagnetic substances. Here the question number 5. Which of the following is true about the value of refractive index of a quartz glass? Here you should know first what is a refractive index. Refractive index is a physical property. Refractive index is a physical property. And here they are asking for the quartz glass. Quartz glass is an amorphous solid. So amorphous solids are in isotropic in nature. Isotropic. What is an isotropic? Isotropic means same value of a physical property in all directions. All directions. So what is the answer? Same in all directions. Option A is correct. Question number 6. Which of the following statement is not true about amorphous solid? Not true about amorphous solid. Here again same reason. Amorphous solids have isotropic in nature. Isotropic in nature means have same physical property, have physical properties same in all directions. So clearly it shows that the fourth option is given, they are anisotropic, but it is wrong because they are in isotropic. So answer is fourth one. Here the question is the short melting point of a crystalline solids is due to. Here the basic point here, crystalline solids are anisotropic in nature, and these are having regular arrangement of constituent particles, and these are in long range order. So due to this reason they have sharp melting points. What is a sharp melting point? Here they melt exactly at one point of temperature. So here answer is option 2. The question is iodine molecules are held in a crystal lattice by. Iodine molecules, coming to the explanation, iodine molecules are non-polar. Non-polar molecules, right? Non-polar molecular solids, I can write. Non-polar molecular solids are held together by London forces or dispersion forces. And I can give you here answer is London forces, and I can give you one more point, and these are these type of solids. These are soft and non-conductor of electricity. Some exams they used to give non-conductor of electricity. Which of the following is non-conductor of electricity? Like that. Which of the following is a network solid? SO2, I2, diamond and H2O. Here coming to the point here, diamond is a crystalline big molecule, we can say gained molecule, and the atoms are in diamond. Atoms are held together by strong covalent bonds. So this is a network solid. So option is diamond is correct option. Here the question is which of the following solids is not an electrical conductor? As we know already seen that I2 molecule, I2 solid is a non-polar solid, and London force of attractions, and these are soft and non-conductor for electricity. Non-conductor for electricity. And here H2O solid they are given. So generally H2O solid, strong hydrogen bonds are present and strong covalent bonds are present before hydrogen bond. Strong covalent bonds, and in solid state, four strong hydrogen bonds are present. So due to this covalent bonds and strong hydrogen bonds, this is a non-ionic solid, and due to the strong covalent nature, this is not act as a electrical conductor. It is not electrical conductor. So answer is iodine is not an electrical conductor and water is not an electrical conductor. So option 3, C and D is correct answer. Here the question is which of the following is not the characteristic of ionic solids? First of all, we see ionic solids. Ionic solids in molten state easily dissociated into ions, and they show high electrical conductivity. So but in the statement 1 they have given they have very low electrical conductivity in the molten state, so that is wrong. So option A is correct. Here the question is graphite is a good conductor of electricity due to the presence of. We know graphite is layered structure. Graphite is layer structure in which free electrons are present. Free electrons are present. And here each carbon atom in graphite is sp2 hybridization. So one free electron is present between the layers. Free electrons present between the layers. So those electrons are responsible for the conductor. So answer is free valency electrons. Here the question is, which of the following oxides behaves as a conductor or insulator depending upon the temperature. So your parameter is temperature. If you see some oxides like vanadium oxide, VO, VO2, VO3 and TiO3 shows metallic in the sense I can say conductor, metallic and insulating property. They shows metallic and insulating property depends on the temperature. Depends on the temperature. It means sometimes if we increase the temperature, if we increase the temperature, metallic nature increases, and if you still increase the temperature, again insulating nature is increasing. Insulating nature is increasing. So it depends on the temperature. So answer is titanium oxide, TiO3. Question is, which of the following oxides shows electrical properties like metals? Some typical oxides like CrO2, titanium oxide and ReO3. These are metal oxides. Metal oxides shows electrical properties. Some metal oxides like MgO, SiO2 and SO2. Even though these are the oxides of metal, semi-metal and non-metal. So these cannot show the electrical properties. Electrical properties. So answer here, which of the following shows electrical properties like a metal means here CrO2 is answer. The lattice site in a pure crystal cannot be occupied by. So here in a pure crystal, the lattice site could be a molecule, or it could be an ion, or it could be an atom, but not it could be an electron, because they said it is pure crystal. For example, I can say diamond is a crystalline form and it does not have free electrons. It cannot have free electrons. But graphite is amorphous. It has a free electron, right? So it could not be an electron. So answer is third option. Here the question is, Graphite cannot be classified as. Graphite is, before going to see the options, graphite is a layered structure. So it is a network solid, right? Network solid. And carbon atoms are bonded by covalent bond. Carbon atoms are bonded by covalent bonds. Covalent bond. So it is a covalent solid. Due to free electrons are present, so it is a conducting solid. But it cannot have dipoles, so it cannot be an ionic solid. Cannot be an ionic solid. So answer is fourth option. Cations are present in the interstitial sites is. So here the question is, when cation means usually smaller ion. When cations move to their interstitial site means cation is dislocated from its normal sites to interstitial site is known as Frankel defect. By the definition only we can say, when a cation is dislocated from its normal site to an interstitial site, so what happened? Cation, so one vacancy is formed, so that is a Frankel defect. Schottky defect is observed in a crystal when, so generally Schottky defect is observed when equal number of cations and anions are missing from the lattice. So due to this, density of solid is decreases. Remember that density of solid is decreases. So answer is equal number of cations and anions are missing from the lattice. Which of the following is true about the charge acquired by p-type semiconductors? Here when 13 group elements means third A group elements, 13 group elements means third A group elements doped with in 14 group elements means fourth A group elements. One hole is created element, so I can say it creates a hole but the electron is just in that say crystal only, but a hole but as a whole, the molecule is neutral. Molecule is neutral. So it means that p-type semiconductor is neutral. So answer is second option. To get an N-type semiconductor from silicon, it should be doped with a substance with valency. In N-type semiconductor, the mobile electrons are present. N-type semiconductor, mobile electrons are present. So here silicon has valency 4. If something is doped with the silicon with more than the valency 4, if anything more valency, if a substance with more valency doped with silicon, so we have excess of electrons. So from the given options, valency 5 is there. So valency 5 is a suitable. Valency 5 is the correct option. Your example is when a silicon doped with P, P means phosphorus, so valency 5, so creates N-type semiconductor.